Hello, everyone. Um, Taking the B out of DBA by Max K, and he'll elaborate on what that means. Take it away.
All right, cool. Hello, everybody. My name is Max K, and I'm giving a talk about essentially attacking ADFS infrastructure. I'll start with an agenda of what I'm going to be talking about. Essentially, I'm going to be giving like a who, what, when, and why of the project, what actually is ADFS, the history of some of the ADFS attacks that I'm sure a lot of people in this room have heard about, and specifically some attacks by APT29 around the whole like SolariGate, SolarWinds compromise. I'm also going to be debuting for the first time a piece of tradecraft that I've been using on red teams that isn't public, and as far as I know, nobody has been using this. Hopefully, yeah, it can be useful for people that attack Windows environments. All right, I'm going to start with the who. I'm a security consultant at WithSecure. I essentially pen tester plus like client relationships, lots of the fun stuff. Of course, my opinions are my own. Don't represent my employers. I do a lot of like operating system security, things like Active Directory, primarily Windows. The last year I've spent a lot of time on macOS stuff. Like I'm a NetSec consultant, so stay away from application security. I have some certs, not that certs really mean anything. I've spoken at some conferences as well, and essentially research hacking and repeat. So a bit of background around this talk. I did a client project with one of my ex-colleagues for like a big banking client. And essentially, we were reviewing some ADFS servers and MSSQL servers. Essentially, we figured out that due to like the domain hierarchy, there were hundreds of admins to these MSSQL servers. And traditionally, ADFS servers should be treated in the same category as domain controllers, because essentially, all of your banking applications, at least if you have like a hybrid topology shared like between tenants, you want to be able to allow this identity flow to be protected. So yeah, they didn't treat them appropriately. The documentation that Microsoft provides specifically says ADFS servers need to be tier 0. They don't say anything about MSSQL servers. So we were like, hang on a second, there's more to abuse there. So yeah, I spent some time abusing them. ADFS compromise is not a fun thing to deal with. I'll be talking about the SolariGate compromise and why APT29 specifically went after ADFS servers, but yeah, you're going to have a bad time if they get compromised. So I'm going to assume that people don't know what ADFS is. Like, I'm sure a lot of people know what ADFS is, but essentially it allows federated identity and access management. So essentially you can have an internet-facing application and allow like a user to sign in with domain credentials or an alternative domain credentials, and it gives you tokens and you can sign into web apps. That's basically the bread and biscuits of it. I'm also assuming that people don't know what the tier model is. It's a legacy model for like protecting assets within Active Directory. It's essentially 3 tiers, similar to like the ring system and the CPU. Like tier 0 is like highly privileged. You don't let anybody have access to it unless it's like break glass or like extreme severe circumstances. Things like tier 1 file servers, like server administrators, servers themselves, like not as important, but still you want to protect them. And then of course tier 2, like standard workstations, users, like if they get compromised, it's not the end of the world. They can't just get domain admin straight away, in an ideal situation, of course. So essentially it's not that easy in like the modern architecture for protecting Active Directory. In reality, it's a little bit more complicated, but I'm not going to go into the nitty-gritty of it. But essentially, you have planes and privileged access, like realms. But yeah, that's an infographic by Microsoft if you want to read about more about it. So essentially, to understand how to attack an environment, it's always helpful to build a lab. So I specifically replicated what they had. Obviously, it wasn't as large of an environment. The environment that we were reviewing had like 600,000 users and like 60,000 machines. It's ridiculous. So essentially, I set up one ADFS server, one MSSQL server, Microsoft Exchange on premises as essentially the relying party. ADFS was the security token service, and essentially the domain controller provided Active Directory domain services. So essentially, if you've seen this screen before, it's likely they use some form of Active Directory federation services. You can log in with your domain credentials, so username, FQDN, pair, and then your password, and you get access to Outlook. Outlook is just one example. There's lots of things you can tie into ADFS, things like your CrowdStrike panel or like basically anything Splunk, yada, yada, yada. So I'm assuming that people don't know the flow, the internals of how ADFS works. If you do, that's amazing, but here's the overview. Essentially, a user says, I want to log into Exchange. It's like, hello, can I have my mail? The Exchange server will redirect you to the ADFS server, so usually like adfs.fqdn of the domain. It says, give me your creds. The user's like, okay, hello, here's my creds. And then the ADFS server asks Active Directory, does this user exist? Is this person who they say they are? And then essentially the domain controller tells the ADFS server, yes, this user exists. Here is the legitimate like identity. The ADFS server returns a token to the user, and then the token gets passed to the Exchange server, and then a login gets granted. So traditionally, there are two ways you can like set up Active Directory Federation services. So there's WID, which is like the Windows internal database. Think of it like Microsoft SQL Lite. It's much smaller, stays on the server itself. There's also, you can use MS SQL servers for like larger environments, traditionally like 100+ trust relationships, so like really big environments, big enterprise environments. It allows like HA, so high availability. It does have some benefits compared to WID, so like no token replay detection, that kind of stuff. So essentially, Microsoft ADFS itself has loads of components, so specifically the .NET components, as you can tell, like the dots in the names. It's a weird little way of identifying .NET. Conveniently, the error messages in the event log give you a lot of information, like full stack traces, that makes reversing things super easy, and it's .NET as well, so DN spy, super, super, super easy. So essentially, the premise behind ADFS is you have a claim. So the user is essentially claiming to have like attributes. So things like you have a condition block, an issuance statement, the query that is essentially going to be made to Active Directory. So traditionally, the parameter that's getting passed to this rule is something that the user controls. So like their username and their password, things like that. And essentially, the ADFS claims engine will do a transform, do the lookup, return the claim information, then build a SAML assertion, and then get passed. Yes, nice, fun IDP stuff. The claims engine itself does processing either on the ADFS server itself, so it will use the config store, either WID or MS SQL for that information. And then a token will get generated, get passed to the user. As you can probably figure out so far, this ADFS server component is pretty important when it comes to like protecting identities or managing identities. So as you know, advanced persistent threat groups like targeting these types of components. The history of the ADFS like compromised chains has always been leading to like a golden SAML attack. I'll be covering what a golden SAML attack is, but essentially you compromise a token, like the token signing cert and token decrypting cert, and you can like forge things, so forge tokens, log into banking apps, do whatever you want. Super impactful stuff. So really, really famous one was the Solari Gate compromise. I'm sure people have heard about it. Can I just get a gauge of who's heard of Solari Gate? SolarWinds compromise in like 2019. Well, good job. Good job. I'm going to explain it then. So essentially, APT29 compromised SolarWinds. So SolarWinds are software provider which provide like monitoring software for like servers and like big banking clients like governments, etc. They all use these SolarWinds components. So perfect supply chain compromise target. So essentially, they compromised SolarWinds with a specific piece of malware called Sunspot. Sunspot was a build process like implant that would swap out C# files with like malicious C# files that had like a component that would get baked into the final signed component that would get sent off to the client. Amazing way to compromise downstream clients. Essentially, it resulted in a backdoor called Sunburst. There were variants of Sunburst that essentially produced a piece of malware called Teardrop. It's super complicated, loads of funny naming schemes as Microsoft like giving. So it was like a long-winded, long-term operation. I wouldn't expect anything much more from APT29. They're super sophisticated. So essentially, Mandiant, FireEye back in the day discovered this like attack chain by essentially noticing weird logins that had like no origin, and they investigated and they discovered this attack chain, this supply chain compromise. So essentially, one of the components was called Foggy Web. So once they had hands-on keyboard like operation through like Cobalt Strike or another command and control software that's not documented, they essentially side-loaded a DLL within the ADFS process that would allow threat actors from the internet to fetch these token decrypting and token signing certs and token decrypting certs. They could also fetch the ADFS config, so they could build their SAML assertions based on the info there, and then essentially like traditional command and control like behavior, so file upload, file download, etc. Super sophisticated, pretty nice. There were a couple of areas which could have been better, like they relied on like PowerShell, but then again, this is like 2019, so it was only when PowerShell started getting scrutinized massively, so yeah. So as I mentioned before, there's a legitimate SAML flow when you log into an application. Essentially, access request happens, you get redirected, authentication happens, signed SAML response gets returned, and then the signed SAML response gets past the actual relying party. That's pretty normal. With a golden SAML attack, when you forge this authentication material, it's missing that ADFS to domain controller authentication like step. So what researchers discovered is you could detect this by correlating like authentication logs between components. So yeah, there's an area to essentially be wary about if you're carrying out golden SAML attacks. I'm going to talk about a very, very interesting component that got discovered during this whole engagement. It wasn't directly associated with SolariGate. However, it's speculated to be once an administrative foothold was achieved on an ADFS server that this malware was essentially installed. It's pretty cool. I'm a massive fanboy of this component. So essentially, if you want the nitty-gritty of how it got carried out, essentially I highly recommend this blog post by Microsoft. It has all of the reversing of the actual component that carried out the malicious activity. This blog post, I love and hate it because they give good details about how the DOL was constructed. However, they don't provide any hashes of the malware because it was so highly targeted. It targeted Microsoft themselves, FireEye, the CIA, like massive players. And obviously they don't want to like let everybody know exactly how you can carry it out. But yeah, with a little bit of ingenuity and creativity, you can do it yourself. Hint, hint, wink, wink. So essentially, the component that they backdoored was this Microsoft Identity Server Diagnostics.dll. This DLL is like one of the first DLLs gets loaded inside the identity provider process or service. This process gets ran as either a service account, a GMSA, Group Managed Service Account, that manages the ADFS process. So essentially, they give steps on exactly how the attack like works. So what happens is Mr. APT29 member goes to log into an app, and they've already backdoored ADFS for this specific company. They present a certificate. This certificate, ADCS certificate, has a specific OID. This OID is like a magic identifier that tells the ADFS process that, hey, this is our backdoored certificate. Whatever the certificate claims to be, you create a SAML assertion and then pass it on to the attacker, and then they can use it later on. So think of it like a skeleton key certificate that allows like complete free reign. The nice thing about that is it doesn't have the artifacts that a traditional golden SAML will have because that authentication process will still happen. It's pretty clean, pretty nice. If you want to like debug .NET stuff, this little snippet is super handy, but yeah. DNSpy, if anybody's done any like .NET reversing, it makes patching DLLs, patching .NET components super easy. So you can just essentially just right-click, edit class, write your own C#, compile, and then you have a patched .NET DLL or .NET EXE. Super easy. So you can kind of like figure out how to put the pieces together to replicate this attack. There's an amazing .NET hooking library called Harmony. It's essentially what I did. I just read the blog post, looked at the like 480p horrible quality Microsoft screenshots, and like kind of figured out after reversing this DLL how I could hook specific components associated with the ADFS authentication process. Currently, I won't be sharing the implementation because it's gross, hacky code that I wrote at like 3 or 4 in the morning. But yeah, at some point I will share it. The thing with the global assembly cache, on Windows machines, you have this assembly cache that have DLLs associated with like a public key token. This allows for like apps to request different components depending on their versions. You can generate this public key and then install it in the global assembly cache pretty easily. So you just use the SN utility, generate your public-private key, generate the public key from the public-private key, and then you have a public key token. This public key token can be used to essentially apply that strong name key to a component, and then essentially you can modify the global assembly cache and then load that specific component. Super easy, just modify the XML, or you can use the GAC util that comes with like the x64 development tools. Yeah, as I said before, I'm not going to be sharing my code because it is not nice code. I'm going to be presenting a technique that doesn't need a foothold on an ADFS server, doesn't need all of these doesn't have all of these IOCs associated with the compromise. As I mentioned, Foggy Web requires a foothold, Magic Web requires a foothold. My technique, no ADFS foothold itself. Foggy Web requires administrator access, Magic Web requires administrator access. Mine doesn't need administrator access. Foggy Web I'm not going to read it out, you can read it. But essentially this technique is super powerful, super difficult to detect, and kind of a pain in the ass for blue teamers. But I am going to be putting my blue team hat on and showing you how you can detect this kind of stuff. So essentially, when you're setting up Outlook web application, Outlook on-prem on an Exchange server, it gives you this guide to set up these essentially issuance transform rules. These rules are essentially the skeleton of this claims transform pipeline. So if you notice the Active Directory user SID and Active Directory user UPN, if I had a pointer, I'd point to it, but those two middle components, it's essentially just like a schema or a skeleton of how this process gets put together, what components come from the user. Essentially, I figured out that based on this claims process, if you can insert items arbitrarily, so if the target company is using MS SQL instead of WID, and you compromise this MS SQL server, which, as I've seen in real environments, isn't treated as tier 0, you don't need a foothold on the box. You just need like SA or equivalent on the MS SQL server. If you're familiar with any of the NetSpy, like Tradecraft, it's super easy to get escalation of privileges on MS SQL servers, either through like relaying, cross-protocol relaying, or essentially just misconfigurations. This component you can backdoor. So I'm going to be showing you exactly how you can do that. As I mentioned before, this claims engine, this process is the trusted component. There are assumptions made that none of the information in here, apart from the parameters that get passed from the user, are untrusted. However, if you can get into this process, then yeah, it's easy to attack. The annoying thing is the schema of the database, when I was trying to figure it out, is absolutely horrible. It's really annoying to figure out. You can monitor what queries get made. However, yeah, it's horrible to figure out. So essentially, when I was researching this claims transform rule language, the claims language, I came across this like token called regex replace. It does what it says on the tin. It does like regex replaces. So in theory, if you bake in a user's username that you know and you have compromised, so say I was the low privilege user, this low privilege user had a foothold on the MS SQL server and could make edits to these claim rules, you can essentially just have it swap out whenever that user is creating a SAML token. So it's super, super powerful. Obviously, that could be any user you wanted, assuming you had the authentication material for that user. There is more to be researched here. There probably is a way of doing it where you don't actually need authentication material. You can skip that domain controller lookup stage, but then it has the pitfalls of the previous like golden sum attack. So I'll probably stick with this way. So as you can see here, I've logged in with this low priv user, and this is like an extract of the SAML, like the SAML information, the XML from the token. The user, the claims has the attribute value of domain admin at contozzle.local. And as you see here, I've basically made it regex replace low priv for domain admin. So yeah, pretty handy. So why is this so stealthy? So no Active Directory Federation server compromise is required. You don't need the token signing cert. You don't need to access the DKMS private key to decrypt the encrypted token signing cert that's in the MS SQL server. No token forgery required, just pure transact SQL, and MS SQL update statements are rarely audited. Yeah, so that's a hint about how you could potentially detect this. I do have a demo, so hopefully this works. If not, I can just, whoops. So as you can see, I'm logging in as the low-priv user. I log in as low-priv inside Exchange. I just copy the URL for Outlook on the web. I make a query for the actual rules. As you can see here, they're just the standard rules for ECP and OWA. Yeah, this is OWA. So the same, pretty default, no backdoor. I make an update statement with these regex replace tokens. I've got this information from the previous query. It's pretty easy to automate. As you see, I have now modified the content in the MS SQL server. There we go, it contains the regex replace for this low-priv user for domain admin. Same for ECP. So I'm going to log in as the administrator to show what it looks like first. I don't know why I did this in the recording, but I did. So I'm logged in as the administrator, I've signed out. I go to log in again. Still the low priv. It takes about 5 minutes to sync between the MS SQL server and the ADFS config. I log in as low priv and huzzah, I am now domain admin logged into ECP, OWA. Cool. So I did give you tradecraft on how you can essentially attack ADFS just with an MS SQL server compromise. I'm going to give you some detection opportunities as well, otherwise I'm a bit of a dick. So AAD internals is like a bible for attacking and defending Active Directory and now Azure stuff. Historically, there is tradecraft associated with compromise of the WID. It's not been documented as much with MS SQL. However, the detection opportunities are pretty similar. So essentially, when an attacker wants to have like persistent access to ADFS and maybe want to carry out like a golden SAML attack in a future scenario, they can essentially set the access controls for the token signing cert to be more permissive, so you don't require administrative access to the server, so you can just fetch the token signing cert as like a standard user. So this is a very easy way of maintaining persistent access to that information. Obviously, you can generate your own audit rules for this behavior. It gives you the actual statement, so like you're updating this identity server policy service settings to be essentially more permissive. Another attack technique is if you had compromised an MS SQL server, you could just read this raw certificate value, which is an encrypted blob of that token decrypting and token signing cert. However, you do need the DKMS decryption key from Active Directory. That attribute in LDAP is highly scrutinized, at least it should be highly scrutinized in a mature environment. So there's a pitfall there. This can also be monitored for on the WID or in the MS SQL server for auditing on select statements on that specific table. The same thing arises for the trick that I showed, essentially having audit actions on update statements for that specific identity server policies database table can be leveraged. So it gives nice information. So here I'm carrying out the attack, and this is the information it gives. It gives the update statement itself, so there's a lot of visibility. It gives the client connecting application name. That would be an amazing place to look for discrepancies. So you see here, I'm just using the PyMSSQL library. In packet, MSSQL client has its own like application name and host name. So it's a very, very high fidelity way of detecting this. So as I said before, the application and host name attributes on the statement, it discloses the connecting application name and the host name for the connecting box. MSSQL client from in packet, it just has a randomly generated host name, so like 8 characters, and application name 8 characters. Super trivial way of detecting this. Other clients have the different name, so .NET SQL client data provider would be the built-in SSMS application. Same with PyMSSQL, it discloses the version name and the application name itself. So super trivial way of detecting. So as I mentioned before, that they didn't treat these ADFS servers as tier 0. You should do the same. As I mentioned before with AAD internals, it's the Bible. He did a talk, 8 ways to compromise ADFS certificates, and he also did say treat the SQL servers as tier 0. The only place on the internet that has that information. So hopefully the information that I've provided can back that up. Microsoft just say secure ADFS as tier 0 system, which is pretty generic. They should specifically say ADFS MS SQL config stores as well, but they don't. Yeah, so here are some references that I used, specifically Praetorian, relaying to ADFS. It goes into like the internals of reversing ADFS itself, super handy. I recommend the Troopers talk and specifically the Hunters, how to essentially threat hunt for ADFS attacks. Yeah, I'll take a photo. This is also a call for help. Specifically, because Microsoft did not release hashes for these components, I would love for someone in here, if they either have APT29 ties or they're friendly people in TI, if they could share a sample. There's an email address there that I've generated specifically for this. So yeah, if you're feeling generous, then scan that and send me a sample. I'd be gratefully appreciated. It will be gratefully appreciated. Cool. And that was taking the B out of DBA. Thank you.